Okay, so today we're going to learn about special triangles, and special triangles are really, really cool. Okay, let's start. So let's start with a square. We know squares, right? Squares, they're all the same side length. Yeah, I didn't draw that really to scale. They've all got a 90 degrees, right? What happens if I take that square and I throw a diagonal down the middle? Down that way. Well, what do I know? Well, these are both the same size, so it doesn't matter what side they are, they're going to be the same length, right? So if I give this a side length of 1, this one has to be a side length of 1. And I just divided that 90 degree triangle, or 90 degree angle into 2. Well, 90 divided by 2 is 45 degrees. So there's special triangle number 1. It's my 1, 1. It's got a 45 degrees here. It's got a 45 degrees here. So any triangle that's got 2 equal sides here is going to have that. And then to figure out my hypotenuse, well, we know c squared equals a squared plus b squared. So c squared equals 1 squared plus 1 squared. Well, 1 squared plus 1 squared is just 2. Square root both sides, and it's root 2. So this triangle is my 1, 1, root 2. And that's a really cool triangle. So if I go to write up my trig ratios, right, we've got our primary trig ratios. So we've got sine angle, 1 over root 2. We have cos angle, 1 over root 2. Oh, they're equal! And we've got tangent, which is 1 over 1. Oh, well, that's just 1. So what do we see here? So in a 45 degree triangle, right? These guys were all 45 degrees. Well, that's what they're equal to. So if I go to do my reciprocal trig ratios, so cosecant is going to be root 2 over 1. So that's just root 2. Secant, well, that's also going to be root 2 over 1, so that's just root 2. And cotangent, well, that's just 1 over 1 again, so it's just 1. So it's really cool. Now, why do I care so much about this triangle? So here I have just a piece of board, right? So this is the kind of board you will use to like trim around, say, a door or something. So if I want to put my trim up and make it nice and beautiful and have like these nice 45 degree angles to the next piece, well, I can just measure it real easy. So here's my ruler. So let's see. This side length is, what's that? 8.8. So if I measure down 8.8 on the side, did I say 8.8? Yes, I did. If I measure this way down, 8.8, let's see here. This is awkward. Right about there. I've just made myself a nice 45 degree angle. So now I know where to cut, and I didn't even have to worry about trying to measure or nothing. That right there is a nice 45 degree angle. So now I know where to cut. Same length, 45 degree angle. Perfect trimming every time. Cool, eh? And that's just a special triangle. So 45 degree angle will always give me that. So there's special triangle number 1. Special triangle number 2. So let's take an equilateral triangle. So equilateral triangle, so they're all the same length. And an equilateral triangle we know is a 60, a 60, and a 60. So if I drop my middle line down to my midpoint, so what's that called, a median? And I split it exactly into 2, well, what have I just created? I've just created a right angle triangle. It's got 60 degrees here. What's half of 60? Well, that's 30. 30 degrees. Okay? And if I make my numbers nice and easy here, so if I made each side length 2, well, what's 2 divided by 2? Well, that's just 1. So there's a 2, there's a 1, there's my 30-60 triangle. How do I figure out my other side? I use Pythagoras. So I know c squared is a squared plus b squared. So here I've got 2 squared equals a squared plus 1 squared. So it's that 4 minus 1 is a squared. 3 equals a squared, square root both sides. A equals root 3. So this is my 1, 2, root 3 triangle, 60 degrees and 30 degrees. So again, we've got a really awesome triangle here that we can use. Let's set up our ratios again. Okay, so let me just drop you down. Well, almost done recording, yeah. Like that was your question, right?
Well, it was more like, when am I done?
So the smaller angles, looking at the smaller side, so there's my 1, my 2, and my root 3. So sine of 30, so there's my 30, so that means opposite over hypotenuse. So that's 1/2. Sine of 60, so if I look up at the 60, opposite over hypotenuse, so that's root 3 over 2. So now I've got all my fractions in there, so now I can solve. So let's see, 1 times 1 is 1, root 2 times root 2 is 2, plus 1 times root 3 gives me root 3 over 2 times 2 is 4. Let's finish it off, common denominator, so let's see, 2 times 2, so that means 1 times 2, what do we get? 2 over 4 plus root 3 over 4, final answer is 2 plus root 3 all over 4. Ta-da! Okay, so let's do one last example here. So just like, so this is out of the homework section. So we want to show that 1 plus cotangent squared equals cosecant squared when the angle is 30 degrees. Okay, so an angle is 30 degrees. That means I'm definitely dealing with my 30-degree triangle. So let's draw that. Because without that, I mean, I don't know what my answers are going to be. So let's see, when I had 30 degrees, so the smaller angle looked at the smaller side, so there's my 1, there's my 2, there's my root 3. Okay, so let's figure out what these things are. So remember cotangent. So the cotangent of 30 degrees, well, that's equal to adjacent over opposite, right? It's the upside down of tan. So cotangent of 30 degrees, let's see, adjacent is my root 3. Opposite is my 1. So I now have that value. Let's figure out cosecant. So we know that cosecant, well, that's equal to, let's see, that's the flip of sine. So instead of opposite over hypotenuse, it's hypotenuse over opposite. So cosecant 30 is 2 over my opposite, which is 1. Okay. So that's good. We can figure that out. So that means, let's check our left side because we're proving. 1 plus cotangent squared theta. So what does that equal? That equals 1 plus cotangent of 30, right? That's what we're dealing with. So that means 1 plus, so that really means cotangent of 30 all squared. Notice where the squared is. That just means it's squared to the outside. 1 plus cotangent 30, we figured out was root 3 squared. Oh, that's good. Root 3 squared, well, that just gives me 3. Oh, that's easy. All right, let's look at our right side. So the right side of our equation is cosecant squared. So that's the same thing as saying cosecant angle all squared. Well, cosecant 30, we just said was 2, so let's pop all that in. Cosecant of 30 squared, we said that that's 2 over 1, so that's just 2 squared. Hey! It's a 4. So, since left side equals right side, therefore 1 plus cotangent squared theta equals cosecant squared theta for theta equals 30 degrees. Cool, eh?